Hello, welcome to this tutorial. In this tutorial, we'll learn about Hofmann rearrangement. So, I have a short PDF about how this rearrangement happens and every minute details of the reaction sequence. So, for a Hofmann rearrangement, it's a reaction that converts a primary amide to a primary amine in the presence of halogen. And this reaction occurs in presence of base and an aqueous medium. So basically, a molecule that has a COONH2 functionality is called as amide, and a molecule with NH2 functionality is called a primary amine. This reaction is basically an oxidation reaction where the amide is oxidized into an amine with the release of carbon dioxide. So just to go into a little bit more detail about how this rearrangement happens, for in the amide, the nitrogen is a electronegative atom. It likes to keep the electron to itself and donate a proton, and a base likes to accept a proton. So in the presence of a base like NaOH, the base accepts the proton from the nitrogen to give a RC double bond O NH negative species, and the OH after accepting a proton is basically water, H2O. Now this species, the N negative, it reacts with the halogen. So Br2 is a molecule which is much bigger and has an electronic distribution such that one of the Br has a delta negative charge and one of the Br has a delta positive charge. So this negative N negative will react with the delta positive Br and will give its electron to delta Br positive, and the Br negative will be released. So you finally will have a species which is a bromoamide. That means in the amide, that is C double bond O NH, instead of an H now you have Br. That's why instead of just amide it's called as bromoamide, and the Br negative is released. Now, like I said that this reaction happens in base, this nitrogen again is electronegative and thus will like to keep the electron to itself and will like to donate its proton to the base. So the base takes the proton, it converts it into RC double bond O N minus Br and it forms a water. And this species is very unstable. So what happens is, this is the species where the rearrangement takes place, and the rearrangement happens because oxygen and nitrogen and bromine, all three species have a lone pair of electrons and thus they participate in resonance. So the N minus charge goes back to carbon, the carbon loses the pi bond to the oxygen and forms a species like RCO minus double bond NBr. And this is the species where from a second part of resonance R migrates towards nitrogen to continue from the previous document. So the O minus, the electron from the oxygen, comes back to the carbon, and the R group, that's the alkyl group that is attached to the carbon, migrates to the nitrogen, and the bromine group leaves as Br minus. This is the species that is called as RNC double bond O, and this is the species that is an isocyanate group. So this isocyanate groups in aqueous medium, like in presence of water, is unstable and it reacts with water. So basically the carbon reacts with the water, it keeps the OH minus, because just think of this carbon, it is bonded to nitrogen which is electronegative and oxygen which is also electronegative, which make this carbon slightly positive. So it takes OH minus from the water, and the nitrogen it takes H plus to give a species which is RNH C double bond O OH. It's an acid because it contains carboxylic acid, and it's a part of a amide group. It's also called as carbamic acid, and this carbamic acid is very unstable. It releases carbon dioxide. So basically the lone pair of oxygen comes back to carbon because again it's very electropositive, and then the hydrogen from the OH migrates to NH to give RNH2 and CO2. So this is how the amide that we started with converts to RNH2, that's amine, in presence of bromine and in presence of water and in presence of base. Thank you.